Welcome to Math on Ice. I'll give you the properties of nth root of a complex number. Now, what is actually nth root of a complex number? I'll take omega is equal to z power 1 by n, which is equal to r to the power 1 by n into cos of theta plus 2 pi k divided by n plus I sin theta plus 2 pi k divided by n, the whole power 1 by n, where k is equal to 0, 1, 2 and so on till n minus 1. So this is called as nth root of a complex number. Now I'll give you the properties of nth root of a complex number. First property is all nth roots of z are in GP. All nth root of z are in GP with the common ratio, that is with common ratio e to the power 2 pi I by n, right? And then sum of the nth root of z is equal to 0. Sum of the roots, that is, if I take the roots of the thing is 1 omega squared so on till omega power n minus 1, nth root of z, all addition, that is a summation, will give you 0. That is 1 plus omega squared plus so on till omega power n minus 1 is equal to 0, where 1 omega squared so on omega power n minus 1 are the roots of the nth roots of z. Next, third property, product of all nth root of z is equal to, product is 1 into omega squared so on till omega power n minus 1, which is actually minus 1 the whole power n minus 1 into z. And then the fourth property is modulus of all nth root of z is same as it is equal to r power n. That is, for example, if you take modulus of nth root of all nth root of z, anything, okay, modulus of all nth root of z is same and it is equal to r power 1 by n or modulus of z the whole power 1 by n. When you take modulus of omega, it is r power 1 by n. Modulus of omega square, it is r power 1 by n. Whatever, when you take the modulus of all nth root of z, it is same and it is equal to r power 1 by n. Now, in specifically, here this is for general z. Z can be any complex number. When you take the particular z is equal to 1, that is the nth root of unity. In that case, particularly if I take nth root of unity, right? In this case, we have z is equal to 1 power 1 by n. That will give us z is equal to cos 2 pi k by n plus I sin 2 pi k by n, which is nothing but the radius is equal to 1. That is what nth root of unity means. Okay. Now, instead of this r power n, here in the previous case, we will have r power n into something, right? So this will vanish as r is equal to 1 here. So for this case, we have certain properties as like the above thing. So what are the properties here? First property, here I will take the nth root of unity, which is z is equal to cos 2 pi k by n plus I sin 2 pi k by n. Let alpha is equal to, if I take cos 2 pi by n plus I sin 2 pi by n, that is actually equal to, alpha is equal to, for if suppose I put k is equal to 1, what happens here? Cos 2 pi by n plus I sin 2 pi by n, right? So this is what, this is actually cos theta plus I sin theta is actually e to the power I theta, right? So here this is in the place of theta, I'm having 2 pi by n. So it is e to the power I into 2 pi by n. This is what our alpha is. nth root of unity can be expressed in the form of 1 alpha, alpha squared, so on till alpha power n minus 1. There we have taken it as 1 omega, omega squared and so on. Here I have taken it as 1 alpha, alpha squared, so on till alpha power n minus 1. This is actually a GP, right? It's a geometric progression with a common ratio. Common ratio, what is here? Common ratio is equal to e to the power 2 pi I by n. Next property is as like addition and multiplication. Here also we have addition 1 plus alpha squared plus so on till plus alpha power n minus 1 is equal to 0. And then the product 1 into alpha squared so on till alpha power n minus 1 is equal to minus 1 the whole power n minus 1. So always the sum of the nth root of unity or sum of the nth root of a complex number is equal to 0 irrespective of the radius. Okay, and for the multiplication product we have here minus 1 the whole power n minus 1. In the above case into z will be there, same thing, minus 1 the whole power n minus 1 into z will be there. And also one more property is added here. Also we have common ratio with e to the power 2 pi I by n. In the same case here we have the nth root of unity are in GP and with common ratio e to the power 2 pi I by n. In addition, we have modulus of all nth root of z is same as it is equal to r power 1 by n. Here when you find modulus of nth root of z, here z is itself 1 power 1 by n. So here r will be 1. Eventually you will have the modulus values equal to 1 here, right? And that's it. These are the major properties of nth root of a complex number and nth root of unity. Thank you.